We are back again on it. I'm going to make sure that you get ready for physics. A steel ball of mass 5 kilograms is rolling over a frictionless surface as shown below. When the ball reaches point A, it has a mechanical energy of 40 joules. So when it reaches here, it in energy, mechanical energy, 490. Now, mechanical energy is the combination of kinetic energy plus potential energy. Take note of that. Ukamvera mechanical energy, combination of those two. Now, 5.1 says, so point B is on the ground. Okay, so that's the ground level. State the principle of conservation of mechanical energy in words. Alright, they're even specific. They know that we can set it in numbers, but they want it in words. So how do we write it? So it states that the total mechanical energy in an isolated system is constant. The total mechanical energy in an isolated system is constant. That's all. It's the same thing like there's that one we say the conservation of energy. Energy cannot be destroyed, cannot be. It's the same thing. But here we're just being specific to mechanical energy. Use your knowledge of the principle of conservation of mechanical energy to write down the value of U. So here we have to write the value of 4.5.2.1. The value of the gravitational potential energy at B. What's the value of the gravitational potential energy? Okay, EP. So the gravitational potential energy at this particular point is 0. This is why in 1 mark. It's simple. On the ground, there is no height. Remember, gravitational potential energy is the energy possessed by an object due to its position. Now, here it is on the ground, so the change in height is 0. So its potential energy is going just to be what? 0. Next. Total mechanical energy at C. Here at C. You can see now that C has some position with a distance of 6 meters. Are we there, right? And the mass is actually 5. But don't worry about that one. Mechanical energy, like I said, it's a combination of potential and kinetic energy. It's also 1 mark. So the same energy it had at this particular point, up Ankara 0, the same energy will move there and be the same. So 490 joules. Remember they are saying mechanical advantage. If they said potential energy, it could have been the different. You could have used the potential energy is equal to mgh. Then we could have put the height there. But they are saying mechanical. It means they're talking about the combination of potential and kinetic together, which is being given as this. We go to 5.3. Calculate the gravitational potential. Okay? Calculate the gravitational potential energy of the ball at C. I haven't talked about it. So gravitational potential energy is given by mass multiplied by height, gravity, and height. That's all. So the mass here is 5. Gravity, we are going to use 10 in our case. Height is, the gravity is usually given in the paper, don't worry. The height is 6. Distance should always be in meters. Take note of that. Check, counter check. So this is 50 multiplied by 6. And I think this is 0 and that is 8. So my potential energy is just 300 joules. All right. Determine by calculation whether the ball will reach point D. Will the ball reach point D there? Oh yeah. So let's go to the only way we can know if the ball will reach that point D there is to first find the velocity. Now we need to use the conservation of mechanical energy. So here is what we are going to do. So part 5.4. We are going to say the change initial. So I'll say mechanical energy initial is equal to mechanical energy final. Now mechanical energy initial, it is at A here. So that will be mechanical energy at A should be equal to mechanical energy at B, at D there, because we are saying it's conserved. So mechanical energy at A, it's a combination of kinetic energy plus potential energy, take note, at A, which is equal to kinetic energy plus potential energy at D. Now, this part is given as 490 joules. You don't have enough to worry about. Here we have half, the mass is 5, we are looking for velocity, plus the mass is still 5, the height, the gravity is 10, the height is 10 as well. We have 490, we have here is just 2.5, then have v squared plus 500. That's what we are having. So let's go to the calculator and punch this together. So we take this side, this one the other side, so we have 490 minus 500 is equal to 2.5 squared. And we have 490, oh sorry, we are going to have negative 10, 2.5 squared. You can start when I divide, I can't find the square root of a number, so my velocity is complex. And from there I can conclude it will not reach on my value. Unless if it was 0, yes, it would have reached, but in this case it cannot reach. All right.